Okay, the first video to get ready for the Endo Exo quiz. In that one, I talked about just basically what it means to be endo or exothermic, so that's we're good there. But I also threw some questions on that quiz about graphs and equations as they relate to endo and exothermic. So that's what I'm going to take care of or cover in this video. So a chemical equation that we've talked about numerous times this year is the reaction that makes water. So we've got hydrogen gas, and remember that's diatomic, that's why this little 2 is there, and oxygen gas, also diatomic. If you react them, you wind up with water. But not only do you get water, you actually get a nice amount of energy in the form of heat. So if you were standing nearby, you would say, oh yeah, I can feel the heat coming off this reaction. I can sense that heat. So this is an example of an exothermic reaction. So exothermic because heat is one of the products. So if heat is a product, it releases heat. And if it releases heat, it gives it off to the environment, and that's our definition of exothermic. So what would this look like as a graph? If we graphed it, if we graphed energy versus time, we would see that since it lost heat energy to the environment, the heat energy went out to the environment, we would say that the products have less energy than the reactants. So to get this reaction to happen, you have to add a little kick, a little spark or a flame or something. And when you add that little kick to get it going, that's called the activation energy. That's why there's this little hill here. But then the atoms rearrange themselves, new bonds form. And when these new bonds form, they actually have less energy in them than the original reactants did. So that's why this graph has a net change of, it goes down. It has a negative heat. It actually gives off heat. So whenever you have the products with more energy than the reactants, that is an exothermic chemical reaction. So since I showed you a graph and an equation for an exothermic reaction, I should probably do an endothermic one. So let me insert a new page here. And what if, and this is something you can do on your own, what if you take some lemon juice, which contains citric acid, and you dump in some baking soda, and science people call that sodium bicarbonate. If you take lemon juice and dump in some baking soda, what happens is you make two new chemicals. One of them is called sodium citrate. Whoops. And the other one is carbonic acid. And that's not really important to us in this class. But what is important to us is that this reaction actually requires heat. So this reaction, you have to actually put heat in to get it to happen. So if you were going to draw a graph of this one, of energy versus time, since you're putting energy in, energy is basically like a reactant. It's on the left side, it's required. That means that the products have more energy than the original reactants did. So these two things over here have more energy than these two things did here. And I'm making this pretty cluttered, so let me clean this up and come right back. And once again, there is this little hill you have to get over to get the reaction completed. But still, what's important for us in this freshman class is that the products, that would be these guys over on this side, have more energy than the reactants on this side. So what if I was standing nearby when this was happening? How would it feel? What would I notice? Or let's, even better, let's say we've got a glass of lemon juice, and we toss in a couple spoonfuls of baking soda, and it's going to make a mess, but let's ignore the mess. What would this person say? This reaction requires heat, so this person would say, whoa, this feels kind of cold. It feels cool, because this reaction is absorbing heat from its surroundings. Probably shouldn't be using blue arrows there, but oh well. So this reaction is absorbing heat from its surroundings to make the products. So therefore, the reaction happening in this vessel would feel cool. So there you go. There is my video on explaining graphs and chemical equations for endo and exothermic reactions.